Here's how you take the squares of the 6 trigonometric functions. Let's start with sine and cosine. So suppose you have the integral of sine squared x dx. So how would we integrate this? Well, first we need to know the half-angle identity for sine. And the half-angle identity for sine squared of x equals 1/2 times the quantity 1 minus cosine 2x. So I'm going to substitute that right here, and we're left with the integral of 1/2 times the quantity 1 minus cosine 2 of x dx. And if I could just pull this constant out, I'm left with 1/2 times the integral of 1 minus cosine 2x dx. Now I'll just integrate it using a power rule. This equals 1/2. Now the integral of 1 with respect to x is just x minus, and the integral of cosine 2 of x is going to be 1/2 sine of 2 of x. And if you think about, if you take the derivative of 1/2 sine of 2 of x, you're going to get cosine of 2 of x times 2 because of chain rule, and that 2 is multiplied to 1/2, which cancels out, and you're left with cosine 2 of x. So in other words, if you take the derivative of that, you will get this, okay, plus c, because it's an indefinite integral. And then what we're left with is the answer. You could also distribute if you want. So this is a valid answer. Or if you want to distribute, it could be 1/2 x minus 1/4 the sine of 2 of x plus c. That's also another answer. Okay. Now, what about the integral of cosine squared x dx? Just like before, we cannot integrate it just like this. We have to know what the half-angle identity is and make a substitution. So the half-angle identity for cosine squared of x equals 1/2 times the quantity 1 plus cosine of 2 of x. So I'll substitute that in right there, and we're left with, now I'm going to go ahead and factor out that 1/2. 1/2 times the integral 1 plus cosine of 2 of x dx. And what I'm left with, if I integrate that just like before, that's going to equal 1/2 times the quantity x, because the integral of 1 with respect to x is x, plus, now the integral of cosine 2 of x is going to be 1/2 sine of 2 of x. So again, the derivative of that is cosine 2 of x, it checks, plus c, and that is the answer for cosine squared. Now let's do secant and cosecant, which should be very easy. The integral of secant squared x dx, what's the derivative of tangent? It is secant squared. So the integral of secant squared is tangent. And that is kind of the relation with derivatives and integrals. And then the integral of cosecant squared x dx is kind of similar. What's the derivative of cotangent? Well, it's negative cosecant. Therefore, the integral of positive cosecant will be negative cotangent x plus c. And if you think about it, the derivative of negative cotangent x would be negative cosecant squared, and a negative times a negative is a positive. So that's why you need a negative cotangent right there. Okay, now let's do the last two, tangent and cotangent. Which is probably a little tricky, relatively speaking, but it's really not that hard. But think about, what does tangent equal? It's sine over cosine, right? Tangent equals sine over cosine. So tangent squared will equal sine squared x over cosine squared x. Okay, this is equivalent to that. And now, can we integrate it just like this? Well, no, not just like this. We have to use a Pythagorean identity for the numerator. Keep the denominator the same and replace the numerator with an identity. And sine squared x equals 1 minus cosine squared x, right? Okay, that is equivalent to that. And now I'm just going to break up the two fractions and the integrals at the same time. So that's what it will look like this. So the integral of 1 over cosine squared x dx minus the integral of, well, cosine squared x over cosine squared x dx, right? That is the same thing. I broke up the fractions with common denominators, and then I broke up the integral sign. Well, this part is easy right here. This is just 1. And what is 1 over cosine squared x? Well, recall from trigonometry, what's 1 over cosine? It's secant. So 1 over cosine squared is secant squared x. Now, the integral becomes easy. What is the integral of secant squared x? Well, we did that right here, and it is tangent of x. And then, what is the integral of 1 with respect to x? It's x, so it's tangent of x minus x plus c. And that is the answer right there. And finally, let's do the integral of cotangent squared x dx. And we're going to approach it the same exact way. What's cotangent of x? Well, in trigonometry, that's cosine over sine, right? So we're just going to have cosine squared x over sine squared x dx. It's almost like doing the inverse of what you did right up here. And we're going to change the numerator with an identity, a Pythagorean identity. Cosine squared x is 1 minus sine squared x. Divide that by sine squared x dx. And I'm going to break up the fraction and the integral. So we have the integral of 1 over sine squared x dx minus sine squared x over sine squared x dx. And what we're left with is that this becomes 1. And what's 1 over sine squared x? Well, in trigonometry, what's 1 over sine? It's cosecant. So this becomes cosecant squared x. And what is the integral of cosecant squared x? It is what we did right up here, negative cotangent. So we have negative cotangent x minus, what's the integral of 1 with respect to x? It's x. And plus c, because it's an indefinite integral. That is the answer, and that is the integrals for the squares of the 6 trigonometric functions. And calculus isn't really that hard. If you know algebra and trig, then it will help you in calculus. And if you know trig, it would really help you in calculus too as well. And it just takes practice and not giving up and whatever your passions are while you're taking this class, or a pastime, a hobby, maybe an instrument or a sport. Do not give up on what you love to do in life, and you will go far consequently. Thank you and have a nice day.